Hi, welcome back to this channel. In this video, we still discuss the chapter alkane, and then is the topic of halogenation. So basically, in this video, we're going to know how to write the chemical reaction of between the alkanes with the halogen, and then we're able to predict the product. And then in next video, we're going to learn about the mechanism of free radical substitution. From the name of halogen of alkanes, so we know that alkanes going to react with the halogen such as bromine and also chlorine to produce the haloalkanes. So from here we know that one of the halogen will replace, one of the hydrogen will replace by the halogen. And then the requirement is there must be with the presence of UV, sunlight, or at a high temperature, which is higher than 100 degrees Celsius. So because of the hydrogen is replaced by the halogen, so this reaction is known as the type of reaction is substitution. And here we need the UV or the heat to make to initiate the reaction. So when the UV will going to produce the free radical, so that's why overall we will consider the type of reaction is free radical substitution for the reaction between alkanes and also halogen. Then do keep in mind that in our syllabus, we only focus that one of the hydrogen replaced by one halogen. So that's why we call here monohalogenation of alkanes. So here, let's look at one of the hydrogen. Okay, when we look at this compound, 2,2-dimethyl propane. So CH3, 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 and CH3, all these four are similar. So any hydrogen replaced by the Cl will produce this structure. So let's say if the hydrogen at the right hand side is not produced, is not replaced. So let's say the top, so you become CH2Cl, CH3, CH3, and CH3. So basically these two products are the same. So that's why we call that this compound or this alkane as equivalent type of the hydrogen atoms, because all of them are primary hydrogen. Okay, so this one is the major product, or we call it, this is the product. Okay, and HCl will consider as side product, or we can call it byproduct. Another example, this is the pentagon, so which we will know as cyclopentane. So again, all this carbon is secondary carbon. So that's why every of this carbon will going to have two secondary hydrogen. So any hydrogen produced also will give similar product, which is chlorocyclopentane. After looking at the monochlorination of alkane with the equivalent type of the hydrogen atom, so now we're looking at non-equivalent type of the hydrogen. So means that these hydrogen are from different classes. So let's say we have propane. This is primary carbon, secondary carbon, and primary carbon. So we have two classes of hydrogen here. So that's why we will going to get two products. One is the replace the primary hydrogen, and then the other one is replace the secondary hydrogen. So the side product is HCl. So in between these two organic compound, later we're going to learn which one is the major product and which one is the minor product. Okay, so now we continue with the second example, the 2-methylpropane, primary, and primary carbon. So this one is tertiary carbon. So means that we have tertiary and primary hydrogen. So when the tertiary hydrogen is replaced by the Cl, this is the product. When the primary hydrogen replaced by the chlorine, this is the product. So again, between these two organic compounds, we need to identify which one is the major product. Okay, now let's continue with the stability of free radicals. So as we know, the bond between carbon and hydrogen will be considered as non-polar bond. So if non-polar bond, the bond will break evenly, which will lead to homolytic cleavage. So the product of the homolytic cleavage will be the free radical, okay, which I write the short form Fr, free radical. So as just now we mentioned that if the propane, there are primary, secondary, and primary carbon. So let's say the primary hydrogen is replaced. So here will become CH2, CH2, CH3, and then the free radical. So if the bond between the secondary carbon and secondary hydrogen is break, so the free radical produced is CH3, CH, and CH3. Then next we're going to classify the class of the free radical. How we classify the free radical is similar with the classification of carbon. So this carbon, free radical carbon, is bonded to one carbon and two hydrogen. So that's why this one is primary free radical. While for this one, the secondary carbon here is bonded to two carbon and then with one hydrogen. So this one is secondary free radical. So then maybe we have to remark here the CH3 or the substituent CH2, CH3 is the example of alkyl group because they fulfill the general formula CnH2n plus 1. And then this alkyl group will be considered as electron donating group, which we can simplify just writing EDG. Similar with the name electron donating group, it means that you try to imagine you have one group of friends who can donate money to you if you are now lack of money. Okay, so you imagine the money is the electron. And then for the secondary free radical means that you have two group of friends which can donate money to you. So between these two conditions, which one is more stable? You have one friend which can donate money to you or two friends who can donate money to you? Yes, definitely. When you have two friends who can donate the money with you, you will become more stable. So if this is the condition, so the more stable free radical will going to form major product. Okay, so now we take another example. Okay, we conclude here. So this is the minor product and this is the major product because secondary free radical more stable than primary free radical because you have more alkyl group, which is the electron donating group. Okay, next one here, like just now we mentioned, this one, if the bond break between tertiary carbon and also tertiary hydrogen, it will form tertiary free radical. Okay, and then for another one is the bond break between primary carbon and primary hydrogen, so we're going to form primary free radical. So tertiary free radical means that you have three friends or three group of electrons that can going to donate to you or share with you, while the other condition is you only have one friend. So definitely tertiary free radical is more stable, and if it is more stable, it will become major product. Okay, so now the tertiary free radical, when react with the free radical of chlorine, will definitely produce major product, and this one will become the minor product. So the HCl is the byproduct. Okay, let's look at the alkane here. So this is the A is the cyclopentane with all the 5 are secondary carbon. While B, this is secondary carbon, secondary carbon, secondary carbon, tertiary carbon, and primary carbon. So, and then this one is tertiary carbon, secondary carbon, primary and primary carbon. So after we classify all these carbon, then now try to look at the question. Which of the isomer above can react with bromine and then with the presence of the UV to give only one monobrominated product? So the answer will be A, because all the carbons in the structure acyclopentane are secondary carbon. So that means they all will have consist same classes of hydrogen. So no matter which hydrogen is replaced by the bromine, so the product will look the same, which is the pentagon. One of the hydrogen replaced by the Br. Next, those which cannot form the brominated product suggest its major product. So as you still remember, among the primary, secondary, and tertiary carbon is the most stable. Tertiary free radical is the most stable. So that's why for structure B, we look at the tertiary carbon is at here. So means that we will draw the structure. Okay, then tertiary carbon means that only have one hydrogen. So this hydrogen is going to replace by the Br. Okay, so then now proceed to the D. So here we have two tertiary carbon, but both of these two tertiary carbon having the same substituent. So same case as well, we maintain, and then one of the hydrogen, the only tertiary hydrogen attached to this carbon will bonded to the Br, and then the CH3 will be maintained. Here the CH3 also maintained. So these are the major products for the alkane which undergo bromination with the presence of the UV. Hopefully by this simple video, you have the idea which hydrogen will be replaced by the halogen, okay, to form the major product. Okay, do keep remember, tertiary free radical is the most stable. So the tertiary hydrogen will be replaced with the halogen. So in next video, we are going to learn about how to draw the mechanism which to show that how the reaction basically is happen involving the bond breaking and bond formation. So see you in the next video. Bye bye.